What is going on, Linear Algebra Bros? It's Mr. C here, and in this video, I'm going to present to you a formula we can use to find the distance between 2 points in n space. That would also be known as the Euclidean distance. And the points will be coming from n space. Keep in mind that we can double up points as components of vectors. Okay, so when we see u equals u1 through un, not only would those be the components of u, but it's also the coordinates of the terminal point of the vector u, and a similar line of logic for the vector v. Now, to help shed some light as to where this formula comes from, I'm going to go ahead and draw a diagram in 2 space, and I'm going to attach the vectors u and v to the origin. This will be the vector u, and the terminal point will have the coordinates u1, u2. And I'm also going to attach a vector v to the origin, which will have components and terminal point coordinates of v1, v2. So what we are looking to do is we're trying to calculate essentially the distance between the terminal points of both of these vectors. Now watch what happens if I add a copy of negative v to the vector u. Okay, negative v is going to point in the opposite direction as v, and if I use the triangle rule to help me out with this addition, negative v will get attached to the head of u. Maybe look something like this. And the resulting vector from adding u and negative v together will be attached to the origin and connect to the tip of negative v. This green vector right here would be the vector u plus negative v, which can be rewritten as direct subtraction of u and v. This vector u minus v can be moved or relocated so that its initial point connects at the head of v and also the head of u. So both those green vectors are the same. Now, if we were to find the norm of this green vector, then that would tell us precisely the distance between the points u1, u2 and v1, v2. So the norm of the vector u minus v would equal the distance. And that's precisely what our formula is that we use to calculate the distance between 2 points. Now there's a special notation associated with a concept like this. It's lowercase d, and in parentheses we write u comma v. Okay, so if you see that notation, it's asking you to compute the distance between the terminal points of the vectors u and v, and that will be found by finding the norm of u minus v. So let me show you how this works within an example. It says find the Euclidean distance between u and v. I know they're using vector notation, but if these vectors are in component form, which we can assume, then these components are doubling up as terminal points. So the distance between the terminal points of u and v will be found by calculating the norm of u minus v. Now if you subtract u minus v, you're going to get the components 2, 0, 2, and 10. Now what I'm going to do here is point out that we have a GCF of 2 that we can factor out from each component, which will help reduce some of the grunt work of squaring the larger numbers and things like that. So I'm going to rewrite this as the norm of 2 times these components, 1, 0, 1, and 5. And we saw a property on the first page of the notes that says that we can take this scalar out provided we apply the regular absolute values to it. Of course, that's going to give us 2. And then that gets multiplied to the norm of the remaining components. Now the norm of the vector having components 1, 0, 1, and 5 works out to be the square root of 27, which is 9 times 3. So, keeping all these factors in mind and simplifying the radical, the distance between the 2 points u and v should be 6 radical 3. And that right there deserves a celebratory dab as well. Okay. Let me know if you have any questions about anything covered in this video. Otherwise, thanks for watching, and I'll see you guys later.